You're listening to The Human Upgrade with Dave Asprey. Can you walk me through mitophagy and what it is, and then why you got into that out of all the fields you could look into?
Yeah, so mitophagy is basically recycling of the faulty mitochondria. So, as we age, our cells accumulate faulty mitochondria. Now, in the life cycle of a mitochondria, what you have is basically you get new growth of mitochondria, and these are called is a process called as mitochondrial biogenesis. As you age, these healthy mitochondria, they accumulate free radicals and reactive oxygen species, and they start to lose shape, and they stop communicating well with each other. Much like, think of it like battery. If battery is not wired with each other, you're not really producing enough energy. And so this sort of recycling process as you put it, dim bulbs as you age. And that's what this molecule Urolithin A does, is it revs up the recycling. So think of your recycling your trash can in your house. If you're accumulating waste in it but never cleaning it out, your house won't smell very nicely. And that's kind of what mitophagy is. You need to have mitophagy up and running as we age, so that you're creating space for newer healthy mitochondria to always produce energy, which is ATP.
That idea of looking at it as recycling is really elegant. When you look at any of the anti-aging things that are out there, not any of them, most of them anyway, there's some aspect of recycling there. You've doubtlessly seen, probably Bruce Lipton is the one who talks about it the most, but lots of people reference a study where a researcher kept a cell culture alive for a ridiculous amount of time by changing the medium all the time until his grad students got drunk and forgot to change the water, and lo and behold, the experiment ends. It seems like that's happening inside each of the major components of our cells. It's happening extracellularly. So there's a lot of cleanup work to do if you want to stay young. And over time, you're going to accumulate metals, you're going to accumulate dysfunctional cells and all of that. Are you feeling hopeful that we're going to be able to do enough cleaning of all the different systems, including obviously mitophagy, but all the other stuff, that we're going to be able to extend the human lifespan that way?
Well, I'm very optimistic that we'll be able to extend human health span, which is, when you're 90, you're able to go about your activities of daily living. Now, how that translates into extended lifespan, this is something where active research is going on with, what is the diet in certain, blue zones where people live longer. But I am very optimistic that you can be a fit 90-year-old and play with your grandchild
I don't know, Dr. Singh. I think that's a bit of a cop-out. So I'm going to share a little story here. Back when I was studying what we called computer information systems, it was one of the first degrees you could get in what would now be called artificial intelligence. And I asked my professors, hey, why don't we just call this what it is? And they said, oh, we can't call it artificial intelligence because no one believes artificial intelligence is real. It'll never happen. That wasn't that long ago. Okay. That was certainly within my lifetime, right? It was only a decade or two. And so when I hear that, oh, we're going to extend health span, it's sort of like that, oh, we shouldn't really say what we're doing because people might not believe us. Do you really think that a healthy 90-year-old who's playing with his or her grandkids isn't going to live longer as well?
No, that's what I'm saying. You need to first, you need to rev up the machinery to make the motor run well. And when the motor runs well, maybe the car will, have a longer lifespan. So I'm just saying that I'm very optimistic that the data today says that health span can be extended. I think that ultimately may translate to extended lifespan, as you're saying.
So you're hedging your bets so no one thinks you're crazy.
No, I think given the knowledge we have today, we probably can realistically extend human lifespan. But what I'm saying is that as a focus, as a clinician, a physician, scientist, my first aspiration, there's many layers, right? You want to go to the moon before you want to go to Mars. So right now we just want to aim to get to the moon, and then I'm sure we'll get to Mars.
I like that. So it's a goal. We'll probably get there, and when and exactly how is it's open for interpretation. I hear you on that, and I actually agree with you there. I'm just willing to say within the next 100 years we'll get there, so that's good enough for me because I'm planning to be there.